All right, let's dive into one of the most powerful and honestly most respected algorithms in all of machine learning, XGBoost. If you've ever been curious about what the pros are using to absolutely dominate those data science competitions, well, you are in exactly the right place.
So think about it like this. If your average, everyday machine learning model is kind of like a bicycle, it gets the job done, it's reliable for sure, then XGBoost, that's the Ferrari. It is just built from the ground up for pure, raw speed and unbelievable precision. And that's exactly why it so often leaves everything else in the dust.
So here's our game plan for breaking down this incredible piece of engineering. We're going to start with why it's such a champion, then we'll get into the super simple idea that powers it. We'll look at the nuts and bolts, figure out what makes it so extreme, put it head-to-head with other models, and then we'll wrap it all up with a really simple analogy that'll make it all click.
Okay, first things first. What's all the hype about? Why is XGBoost the go-to tool for so many data scientists out there?
The answer really is pretty simple. It just gets results. XGBoost has this legendary reputation, and it's a reputation that was built by winning some of the absolute toughest data science competitions on the planet, like the ones you see on Kaggle. It's not just a little bit better. It brings this game-changing mix of incredible accuracy and high-speed performance that really puts it in a league of its own.
Now, to really get XGBoost, you first have to understand the core concept that makes it tick. It's a technique called boosting. And believe it or not, it's based on a really simple, totally human idea, learning from your mistakes.
Just imagine we're playing a little weight guessing game. Let's say you take a shot and guess someone's weight is 75 kilograms. Turns out the actual weight is 80 kilos, so your error is 5 kilos. Now here's where the boosting magic happens. Instead of you just trying again, you bring in a friend. But this is the key. You don't ask your friend to guess the person's weight. No, you ask them to guess your error.
So your friend looks at the situation and guesses your error was about 4 kilograms. Now you just combine your original guess with their correction. 75 plus 4 gets you to 79. And boom, just like that, you are way closer to the right answer. That, in a nutshell, is the entire philosophy behind boosting.
So what's the big takeaway here? Boosting is all about building a team of models, but they're built one after the other in a sequence. Each new model that joins the team has one very specific job: fix the mistakes that the models before it made. It's basically teamwork, but for algorithms.
Okay, so that's a nice little story. But how does that simple game actually turn into a super powerful, complex algorithm? Let's take a look at how XGBoost actually puts this idea into practice.
You see, in XGBoost, the team members are something called decision trees. You can just think of them as simple little flowcharts that make predictions. So the first tree makes a guess. Let's say it predicts a house price is $500,000, but the actual price is $1 million. Whoops! That's a huge error of $500,000. So what does XGBoost do? It builds a second tree, but this second tree's only job is to predict that $500,000 error. The final prediction then becomes the guess from tree 1 plus the correction from tree 2. And it just keeps doing this over and over again, sometimes hundreds or even thousands of times.
This is what brings us to the X in XGBoost. You see, regular boosting is already pretty smart, but XGBoost just kicks it up to a whole new level with some really brilliant engineering tricks. These are its power-ups.
XGBoost really has 4 secret weapons that give it that extreme edge. First, it's blazing fast because it's built to use all of your computer's processing power at the same time. Second, it has this kind of self-control feature called regularization. This is so important because it stops the model from just memorizing the data instead of actually learning the patterns. It keeps the model honest. Third, it's smart enough to handle missing data all on its own. And finally, it's super efficient, automatically pruning or chopping off the weak parts of its trees that aren't adding much value.
So, with all those power-ups, how does XGBoost actually stack up against other popular models you might have heard of? Let's put them head-to-head.
So let's compare. A standard decision tree? That's just one model making one guess. A random forest is a bit better. It's like an election where a bunch of independent trees all vote on the answer. But XGBoost's method, this boosting thing, it's totally different. It's a sequence, a chain of models, each one learning from the last one's mistakes. And the result of that process is pretty clear. You get a very high level of accuracy. This thing is literally designed to systematically hunt down and stamp out every last bit of error. To wrap all this up, I want to leave you with one final analogy that just perfectly captures the spirit of how XGBoost works. I want you to picture a professional golfer trying to sink a really tough shot.
The first model is the drive. It's powerful, it gets the ball way down the fairway, close to the hole, but it's not perfect. So the second model is the approach shot. Its only job is to correct the error from that first big swing and land the ball right next to the pin. And then the final models, well, those are like the putt. Just small, tiny, precise adjustments to get it exactly right.
And that's really the whole idea, isn't it? By summing up all of these sequential, corrective shots, you guide the prediction exactly where it needs to go. It's not about finding one single perfect model. It's about building a team of specialists that work together to achieve perfection.
When you really think about it, the power of XGBoost isn't just the code itself. It's this profound idea of learning and correcting, step by step. It kind of makes you wonder, doesn't it? What impossible problem could you solve if you had a team that could learn perfectly from every single one of its mistakes?